Hi, my name is Anjali and welcome back. Today we'll learn how to detect loop in the linked list. For example, if we have 1, 2, 3, 4, 5, 5 is pointing to null, we need to return false as there is no cycle. Whereas if we have 1, 2, 3, 4, 5, 5 is pointing to 6, 6 is pointing to 7, 8, 9 and again 9 node is pointing back to 6, we need to return true as we can clearly see there is cycle starting from 6. So to detect a cycle in linked list, we will use slow and fast pointer approach. And if you have any doubt about the slow and fast pointer, I highly recommend you to watch the video before moving on. Link is given in the description below. So if there is no cycle, meaning the last node will point to null, which gives us two cases. First, when the length of linked list is even, then we will get the condition fast is equals to null. How? So fast is initially pointing towards the head node. In the first iteration, it will jump to third node. This is first iteration. In the second iteration, it will jump to fifth node and eventually it will jump to null. That is what it is written over here. Second point comes when the length of linked list is odd, meaning fast dot next will become equals to null. Fast is initially pointing towards head. In the first iteration, it will jump to 3, then 5, and it cannot jump further on, meaning we will get fast dot next equals to null. I hope these conditions are clear, and if not, I recommend you to watch the video again. Moving on to another example where we have cycle within the linked list like this over here. What we can say is neither of the slow or the fast pointer will point to null. Second point says fast will enter the loop first and keep on circling within the cycle. Third point says slow pointer will eventually enter the cycle. Therefore, the meaning of 3 points is that we have nothing to do with this specific part because eventually slow and fast pointer will enter within the cycle, which means there are nodes within the cycle, right? We have cycle, we have nodes like 1, 2, 3, 4 connected in clockwise direction, meaning 1 is connected to 2, 2 is containing address of 3, 3 is containing address of 4, 4 is containing address of 1, which two pointers slow and fast somewhere within the cycle moving with different speed. So for that specific case, there is one algorithm. The algorithm is known as the Floyd's Tortoise and Hare algorithm. Let's see what it says. So Floyd's Tortoise and Hare algorithm detects cycle in linked list using two pointers. The tortoise slow pointer moves one step at a time and the hare fast moves two steps at a time. If there is cycle, the hare catches up to the tortoise, meaning that they both should meet. We have two pointers and they both will eventually meet. Slow and fast pointer should coincide. So let's understand this specific algorithm mathematically. Let's begin with the mathematical proof now. So what all is given to us? That we have nodes within the cycle. Initially, slow pointer is pointing at the node A, fast pointer is pointing at the node B. Let the initial distance between slow and fast pointer be equals to x, which is given over here, which means that a minus b is equals to x. This is our first equation. The distance between slow and fast pointer be equals to x. After first iteration, slow will jump from a to a plus 1, whereas fast will jump from b to b plus 2, which means the new distance between slow and fast pointer be a plus 1 minus b plus 2, which is equals to a minus b minus 1. And we know that a minus b is equals to x from equation number 1. Putting that value over here, it becomes x minus 1. So we can say the distance between slow and fast pointer is reduced by 1, which means that slow and fast pointer will coincide at the x iteration, where x is equals to initial distance between slow and fast pointer. So if initially x is equals to 5, in the first iteration the value is reduced to 4, In the second iteration, the value is reduced to 3. In the third iteration, value is reduced to 2. In the fourth iteration, value is reduced to 1. And finally, at the fifth iteration, which is the value of x over here, they will finally coincide. Slow will become equal to fast pointer. This is end-to-end working example of what we have learned so far. So hence we proved two things over here. Slow and fast pointer will always meet, and they will meet at the x iteration. In case if you have any doubt at any point, please pause this video and observe this example carefully. Also, I will add this example in the description. Now it's time to jump to pseudocode. So the pseudocode would be very easy. We need to have two pointers, slow and fast pointer, pointing towards the head node. We know our exit condition while fast is not equals to null. When we get fast is equals to null, then the length of the linked list would be even. And when fast dot next is equals to null, it meaning the length of the linked list is odd and there is an exit position. And inside the loop, slow will move one step ahead, so slow will move to next pointer, whereas fast will move two steps ahead, fast dot next dot next. If at any point they coincide, meaning slow is equals to fast pointer, then we need to return true. There is no point in checking further, and we have a cycle within the linked list. But if they come out of the loop, it means there is no cycle within the linked list, and then we need to return false. I hope this code is clear to you, and if you have any issue, please rewind the video and watch it again. Now it's time to solve this question on LeetCode. So this is problem number 141, linked list cycle. So we'll start writing our code. First, we need to have our slow pointer pointing towards the head node, fast pointer pointing towards the head node. Then we have our exit condition while fast is not equals to null, and then fast dot next not equals to null. Keep on going, and slow will move one step ahead. Slow is equals to slow dot next, and fast is equals to fast dot next dot next. If slow is equals to fast, we can return true because there would be cycle. Else, if it comes out of the loop, we need to return false. Let's try to run the program. So you see all the test cases are submitted, and finally we'll submit the program to see if all the test cases are submitted. There you go. Now it's time to have a cup of coffee and work on follow-up question. The question here is that you are given the head of a linked list and you need to return the node where the cycle begins. If there is no cycle, you can simply return the null. For example, here you see that the cycle begin at the node 2, so you need to return node 2 over here. In the second example, you need to return 1 because cycle starts over here, 1, 2, 1, 2, 1. In the third example, there is no cycle, so you can simply return null. So that is all for the follow-up question. Try to solve this example by yourself. And if you face any difficulty, we will solve this question in follow-up video. Link for this question is given in the description below. I hope you have enjoyed this video very much. Notes are available in the description below. Please do like, share and subscribe. We'll meet in another video. Till then, bye bye. Take care.